Hi, I want to present you my library in linear algebra with complex number. I have chosen to speak about how to balance chemical equation. How to balance chemical equation. We work with real value even if I work with my library or in linear algebra with complex value. In first, I want to balance this chemical equation. Alors, the first thing, I must create a system. Then I must resolve this system. Then in the first part, I compute the coefficient how to equilibrate this chemical equation. First I must create the system. Now this is my chemical equation. I must create a system of linear equation. Perhaps I must create my this is my chemical equation. I have create a system of linear equation. In the first line I put the carbon. In the second line I put the hydrogen, and in the first line I put the oxygen. Okay. In the first column I put this element. In the second column I put this element. In the first column I put this element, and in the fourth column I put this element. This is the first element I put in the first column. Alors, I have a carbon, also I put one carbon. I have 4 hydrogen, I put 4 hydrogen. This is for the first element. Now for the second element, I write with the second column. I have 2 oxygen, I put 2 oxygen. This is for the left part of my chemical equation. Now I work with the right part of my chemical equation. This is the third element. I copy in this third column the element. Alors, I have 1 carbon. I put 1 carbon. I have 2 oxygen. I put 2 oxygen. 1 carbon. And because I am on the right of my chemical equation, I must put a minus sign. Because I am on the right of my equation, I put a plus sign when I write with this value, and I put a minus sign when I work with this value. Now it is the last element, the 4 element. I work with this 4 column. Alors, I have 2 hydrogen. I put 2 hydrogen with the minus sign because I am on the right of the chemical equation. I have 1 oxygen. I put 1 oxygen with the minus sign because I am on the right of the linear equation. Now I must copy this system of linear equation. I copy the system of linear equation, and I introduce this system. And I introduce this system in the second sorry aussi. Je vais tous les faire. Sorry, voilà. And I introduce this value that I have into the second, in the second part. Alors, resolve the linear system of linear equation. Alors, I copy this code into my editor. I work with complex value, but to simplify the explanation how to obtain this linear system, I have worked with real value, but here you have complex value. This is a real part and this is a imaginary part. This is a complex value. Okay, you have 2, minus 1, minus 2, minus 1, minus 2, minus 2, minus 1, minus 2, minus 1. But this I have create here a linear system of equation with real value, and now I have create this system with complex value. Why? Because I work with my linear algebra with complex value, so I arrive this part. Now I want to resolve this system of linear equation. I can see I have three line, okay, but 4 columns, 1, 2, 3, 4. This is B and this is A. Okay, so if I want to resolve this system, I must introduce linear free variable. Alors, this is my linear system of equation with A and B, 3 line, 4 column. I use the Gauss-Jordan partial pivoting. This gives this value. This don't give don't resolve the system. You have 1, you have 1, you have 1, but you have this value and you have this value. Why? Because you have a linear system with 3 lines and 4 columns. So you must introduce 3 variables to resolve the system. So I call the function, this function. This function put a line of 0. Now I have 1, 2, 3, 4 columns. This is B and this is a new column, and 1, 2, 3, 4, and 1, 2, 3, 4. Now I have a system of linear equation with 4 lines and 4 columns. I can use Gauss-Jordan to resolve the system. Now in here I have put the row 0 and the column of 0. And now I put the 3 variable. You have here the new line, and this is the new line, and I have put the 3 variable. Here I have put the 3 variable. If I put the 3 variable here, I must put this value in the 3 column. This is a column for the 3 variable, and this is the line with the 3 variable. Okay. Now I call the Gauss-Jordan function and resolve the system 1, 1, 1, 1. This system. This is A, and this is B. This is B, and this is a column with the 3 variable. This is the result of my linear system of equation. I copy this value here. The B plus the 3 variable. This is a 3 variable. Okay. And now I copy the three variable into x1, x2, x3, x4, x1, x2, x3, x4. Now copy and paste this code in the next C file. I copy this value. I copy this value and I go in the next file. Alors, sorry. Alors, this is the system of linear algebra. In complex value, you have z. This is a complex value function. This is alors, I print here the system of linear algebra only with the real value. You have only the real value. Why? Because I use this function. If I erase this R and if I add this command, now, sorry, I have the result with perhaps 1, 2, 3, 4. Sorry. Now I print. Oh là, qu'est-ce qui s'est passé? Alors 3. Now I print AB with complex value. Okay? You have here complex value. Why? Because I have used this function. If I use this function with R and I erase this command, now I print A with only the real value. So this is the first. Here I call the function Gauss-Jordan. Is la fonction Gauss-Jordan, partial pivoting. I call this function here. Now with this function I put the 0 line and the colon 0 for this colon for the free variable and this line for the free variable. This is this function. Now I use this function to put the free variable. To put the free variable, I must add 1 here. I must add 1 here, and I must add 1 here. In this way, I have put the free variable in this linear system of equation. Now I have put here this work. Now I call the Gauss-Jordan. This resolves this system. You have the free variable here, the free variable here. You have A here and B here. And now I copy B of AB down B3. B3 is here. And then I call this function with write this code. This function will write this code. Okay. Alors, compute the coefficient. In first, I have compute the value of the free variable, okay, but these values are not integer. These values are not integer, so I copy this value. I have copy here. I have copy here, and now I introduce this value in this new file. In this new file, I copy this value into this new file. This new file give me the coefficient for the chemical equation. Alors, continue until integer appear. You have here no integer. You have here decimal number. You have here decimal number. I press return to continue. Now I have integer 1, 2, 1, 2. Okay. So I can press X to stop. Okay. Alors, this is my chemical equation. I have compute x1. Oh, sorry. I have compute x1 equal 1. So x1 equal 1. x2 equal 2. x2 equal 2. x3 equal 1. x3 equal 1. And x4 equal 2. x4 equal 2. And x4 equal 1. Now I have balanced this chemical equation with a linear system of equation. Now I press X and I stop this example. Now I try to resolve this new chemical equation. This is the new chemical equation. Alors you have sodium, or natrium, sodium. You have the sodium. This is my new system of linear equation. The first element is sodium, so the first line is for the sodium. You have here hydrogen. So I use the second line for hydrogen. You have oxygen, so I use the third line for oxygen. Sodium, oxygen, hydrogen, oxygen. Okay. Now this is my system of linear equation to resolve this, to balance this chemical equation. The first column is for this first element. The second column is for this second element. This first column is for this third element. You must put the sign minus because this element is on the right of the chemical equation. And this column is for the four elements. These four elements. No. This is the first element. You have sodium. 1, so sodium. You have 3 hydrogen. You have 3 hydrogen. This is for this element. This is the second element. You have 2 oxygen. You put 2 oxygen into the second column. You have 2 oxygen in the second column. Now I must work with the third and fourth elements. Alors, the third element, you have 1 sodium. I put the minus sign because I am on the right of this chemical equation. Now you have oxygen, 1 oxygen, so I put 1 oxygen. I put the sign minus because I am on the right of this chemical equation. Now I want to work with element. This is a 4 element, so I work with the 4 column. You have 2 hydrogen with the sign minus because you are on the right of the chemical equation. you have one oxygen. I put one oxygen. I put the sign minus because I am on the right of the chemical equation. I copy this value. And then I go to the second. Resolve this linear system of equation. I work with this truc. Alors, minus, minus. I work. Alors, resolve the linear system of equation. I copy this file into my editor. I copy this system of linear equation that I have right. Okay. Alors, this system of linear of equation is right with real coefficients. Why? Because it is easy to understand my algorithm. But I work with complex value. So I must edit this part. This part is for complex value. Okay? So you have 1, 3, 1, 3, 2, 2. This is the real part of the complex value. Minus 1, minus 1, minus 1, minus 1, and minus 2, minus 1, minus 2, minus 1. This part is the real part for the complex value. This part is a complex value. Imaginary part. Okay. Now I call this example. I try to this example. This is my linear system. You have three line, but 4 column. 1, 2, 3, 4 column. This is B, and this is A. So I must introduce three variables. Alors, in first I call the function Gauss-Jordan partial pivoting. This gives 1, 1, 1, but I have this value and I have this value. I'm not able to resolve this system with Gauss-Jordan because I have 3 lines and 4 columns. So I put a new line. I put this new line into this system of linear equation. I put this new line. If I put this new line, I must put a new column for the free variable. This is a column for the free variable, and this is a line for the free variable. Now, I put here the line for the free variable and the column for the free variable. Now I put the free variable. This is, you have here no 1, this is, you have 1, this is the free variable. If I introduce the free variable in this column, I must introduce the free variable in this column also. This is a column for the free variable. Now I have a system with 1, 2, 3, 4 columns. This is B. 1, 2, 3, and 4 line. So I can call Gauss-Jordan, and this resolves the system. 1, 1, 1, 1. This function resolves the system. This is the value of the free variable, the result that I want. I copy this value, B and the free variable here. I copy B and the free variable here. And then I save the free variable, this value, into x1, x2, x3, x4. x1, x2, x3, x4. I copy and paste this code in the next file. So I copy this value. I copy this value. And I go into compute the coefficient. compute the coefficient. Okay. This is the value that I have computed. I copy this value here. Now I want to compute the coefficient of my chemical equation. Alors, continue until integer appear. You have here integer value. You have here decimal number. You have here decimal number. So I press return to continue. You have here decimal number. So I press return to continue. You have decimal number. You have decimal number. So I press return to continue. You have here decimal number. So I press return to continue. You have decimal number. So I press return to continue. Continue until integer appear. And now you have integer 4, 5, 4, 6. This is the coefficient of my chemical equation. This is the coefficient of my chemical equation. Alors, this is my chemical equation. Alors, x1 equal 4, so I put 4 here for x1. x2 equal 5, so I put 5 in my chemical equation. x3 equal 4, so this give 4 for my chemical equation, and x4 equal 6. Sorry, x4 equals 6, and I have the result. Oui. Ok. Donc, I have introduced my linear system of equation with this part. I have create my system of linear equation. I have print the system AB. I have used Gauss-Jordan partial pivoting, perhaps. I have used Gauss-Jordan partial pivoting. This gives this system of linear equation. I have not resolved the system. You have here this value. Why? Because I have 4 columns and 3 lines. So I introduce 3 variables. A line of 0, and a column of 0. This is the first part. In second part, I put the 3 variables. Here, I put the 3 variables, and I put the 3 variables here. This column is for the 3 variables. Now, I have a system Gauss-Jordan. Donc, I put the 3 variables here. Here, I put the line of 0 and a column of 0. Now, here, I put the 3 variables. Now I use Gauss-Jordan. Why? Because I have 4 columns and 4 lines. This gives this result. This is B. This is A, and this is the value of the free variable. I save the free variable here. Then I copy the free variable into x1, x2, x3, x4. Alors, I save the free variable here. I copy b of ib down b3. You have b3 here, and in this function give this value, give the code or with the free variable, and this free variable, I copy this free variable into this new file. I copy this free variable into this free file, and this file continue until the integer appear 1, 2, 3, 4, 5, and when you repeat 6 times, you find the integer pair, and this value are the coefficient of my chemical equation. Alors, I have tried to work with my linear algebra with complex value library. I have tried to work. I have do the same work, but with my real complex, my real library, linear algebra library. You can go here. You can find here. Okay. And you have here the same work, but this time only with real value. You can try if you want, only with real value. The same work with real value. Voilà. Alors, you can go here and you can linear algebra with into here, R, and linear algebra into C, in C. Thank you.